What if I told you the most logical, most economical place to run the next generation of AI wasn't some massive data center on Earth, but in orbit thousands of miles above our heads? Yeah, it sounds like something straight out of a sci-fi movie, but it's a very serious prediction.
And get this, that bold claim comes directly from Elon Musk. We're not talking decades from now. He's talking about a timeline that's less than 3 years away. It's a statement that, honestly, seems almost impossible at first glance.
So, is this just hype, another wild prediction? Or is there a cold, hard physical reality behind it? Okay, let's actually dive in and unpack the argument, step by step. And it all starts with a huge problem that AI is creating right here on the ground.
Musk's entire case, this whole crazy idea, hinges on one fundamental thing that most of us never even think about: electricity. And when it comes to AI, we are about to hit a massive wall.
Here's the core issue, right? The power and production of AI chips are just exploding. They're on this insane exponential curve. But our global electricity output, for the most part, it's been basically flat for years. You just can't run an exponential technology on a linear power source. Something has to give. And this visual, man, it really drives the point home. You see that huge gap? That's the crisis. AI's hunger for power is shooting for the moon, while our ability to generate that power is stuck on the ground. This isn't just a small gap, it's a chasm that's getting wider every single day. We're on a collision course. As Musk bluntly puts it, you can't just wish this power into existence. For a long time, tech has lived in software land, but now it's getting a hard lesson in hardware. The physical world has very real limits.
And the problem is actually way bigger than it seems. The power rating you see on a chip, that's just the beginning. Think about it. You have to cool these massive data centers, which can take a 40% power increase right there. Then you add another 20, maybe 25% for service redundancy, and you quickly realize the real power you need is almost double what the chips themselves say they consume.
So you're probably thinking, well, why not just build more power plants? It's not that simple. The world of heavy industry moves slow. Just getting permission to connect to the grid can take a year-long study. The special blades you need for gas turbines, they're sold out until 2030. You throw in massive solar tariffs and the nightmare of getting land use permits, and you see that scaling power on Earth is just incredibly slow and incredibly difficult.
Okay, so if Earth is the problem, the argument goes that space is the solution. Let's dig into why this sci-fi idea might actually be a very real, very logical answer. This is where it all clicks. It's just raw physics. On Earth, our solar panels are fighting against the day/night cycle, against clouds, against weather. The atmosphere itself blocks about 30% of the sun's energy before it even reaches a panel. But in space, you get 24/7, unfiltered, direct sunlight. A solar panel becomes this unbelievably effective machine.
And that raw effectiveness just completely rewrites the economic equation. A panel in orbit is about 5 times more productive than one on the ground. Plus, since you have constant power, you can get rid of the huge cost of battery systems. You combine those two things, and you get a seismic shift. Space-based solar becomes an order of magnitude that's 10 times cheaper. This isn't just a small improvement, it's a total game changer. It can make compute power, for the first time ever, a nearly post-scarcity resource.
Okay, so the power is cheap and abundant up there. Fantastic. But that's just the first step in what is a monumental engineering challenge.
This is the next logical question, isn't it? It's one thing to say there's power in space. It's a whole other thing to actually build and operate the infrastructure you need to use it.
According to Musk, this isn't one problem you can solve. It's 3 massive interlocking problems you have to solve all at the same time. First, you need a cheap way to get a ton of stuff to orbit. That's Starship. Second, you have to be able to mass produce the solar panels. And third, you have to crank out enough AI chips to keep up with the first 2. They all have to work together.
Now, just to wrap our heads around the unbelievable scale of this, to get enough hardware into orbit for hundreds of gigawatts of AI, we'd need something like 10,000 Starship launches a year. A year! That works out to a launch every single hour, 24/7. It's an industrial operation on a scale humanity has literally never even attempted.
And this is where the thinking gets really fascinating. Musk argues that by the end of this year, the bottleneck for AI on Earth is going to be electricity. But once you solve that by going to space, a new constraint pops up, actually making the chips. It takes about 5 years to build a new chip factory from scratch. The limiting factor just moves up the supply chain.
So you see, this isn't really just about building data centers in a new location. It's about a fundamental reimagining of how we operate on a civilizational scale.
This whole vision ties into a concept called the Kardashev scale. It's a way of measuring how advanced a civilization is based on how much energy it can harness. Here on Earth, we only get a tiny, tiny fraction, about 0.5 billionth of our sun's total energy. The only way to capture more, to fundamentally level up as a species, is to go to the source and build in space.
And the outcome of all this exponential growth, all this power, is an intelligence that could completely reshape our world. An intelligence that vastly exceeds our own, powered not by the limits of Earth, but by the boundless energy of a star.
And so, that really leaves us with the ultimate question. If this vision actually becomes a reality, and an intelligence potentially millions of times smarter than all of us combined is born not on our planet, but out there among the stars, what does that mean for us down here? It's a future that is somehow both profoundly inspiring and deeply unsettling to even think about.